Alright, it's time for another episode of Back to Basics, and we're going to return back to the subject of resistors because, as Jose pointed out in the comments, I left potentiometers out, and that was a bit of an oversight on my part, so apologies there, but we'll get caught up now, and we'll dedicate an entire video to potentiometers. So, what is a potentiometer? Well, it's a variable resistance that can be measured at 2 points, so it can act as a voltage divider. Now, what does a potentiometer look like? Well, when you're looking at a circuit diagram, it will look like this, or like this, or sometimes like this, and sometimes like this, depending on whether you're from the US or Europe or whatever. In this case and this case, they're called rheostats, and that's a slightly different function of a potentiometer where you only use half of it. Anyway, so how does a potentiometer work? Well, it works like this, and they look a bunch of different ways. One is like this, sort of a volume slider, also known as a fader. You'll also see ones like this, which you've seen on the channel before when I was building my power supply for the LEDs, and you'll need a little screwdriver to change the value of that one. You'll also see ones like this. This is called a dual gang potentiometer, which is two potentiometers stacked on top of each other, and in this case, this one is logarithmic. And so you'll have the little knob that you twist. You'll see other ones like this, which have a switch built into them, and then you change the value, so that turns on whatever circuit is and then changes the value of the potentiometer. You'll also see ones like this. This is a multi-turn potentiometer, so it's got 10 full turns on that shaft before it reaches the end. That's used for high precision situations. And then we've also got ones like these, which you've also seen on the channel before, which are also multi-turn potentiometers, just very small wattage. So how are these things built? Well, in the case of the fader, you're going to have a contact, a strip of some sort of resistive material, and then another contact. And then you're going to have a little thing that comes down and has a little wiper that makes contact with that resistive material. And then it's going to make contact with a rail. And then you're going to have your little handle on the slider. So what happens is this strip here has basically no resistance. It's just a piece of steel or copper or aluminum or whatever. Makes contact with this, which is in contact with the wiper, and then the wiper moves up and down on this resistive material. So if you were to take a reading of resistance with it in this position between these 2 points, that resistance is going to have to travel all the way through here and then back out. So you're going to get the max resistance. In this case, this is a 20 k ohm resistor. But if you take a resistance reading between here and here, being as the wiper is all the way at the end, it's going to be 0 ohms. And then as you move this slider down, this resistance is going to start going up, while this resistance starts to go down. Now, well, let's actually also talk about the round ones. The round ones are going to have a similar setup, only the wiper is going to be like this. And then, of course, it rotates around like that. Now, this conductive material can be made, or resistive material rather, can be made out of any number of things: carbon impregnated plastic, nickel chromium. It can be in larger potentiometers. It can be just a coil of thick wire. There are any number of ways of doing it. All you need is something that increases resistance as you move down it, and then something to make contact with it so that you can change the resistance. And of course, if you put a voltage into here, and then you take a voltage reading from here to here, and from here to here, that voltage is going to divide linearly as you change the potentiometer. Unless it's a logarithmic potentiometer, then it's going to change logarithmically. But in time with the resistance, of course, the voltage on either side of that will increase or decrease based on where you're turning the knob. Now, I talked briefly about a rheostat earlier. Now, what's a rheostat? Well, a rheostat is when you only need half of the function of a potentiometer. So, in practice, and I've never actually done this myself, but you're supposed to, you short out 2 leads of the potentiometer like that. So this reading here doesn't mean anything. So that goes in one side of your circuit, then this goes into the other side, and then you can increase the resistance and you can decrease the resistance. Typically, you will have additionally a resistor on there so that you have a minimum resistance. You don't want to just have a short. But yeah, so that's how you use it as a rheostat. That's how I use it in my linear LED driver to set the current sense. I use it as a rheostat. But in my pulse width modulation circuit, I used it as a potentiometer to change the ratio of the resistors that set the mark space ratio or the pulse width or the duty cycle. So that's when you'd use it as a potentiometer. There are also audio applications that change the ratio of voltages going to the amplifier so that it increases or decreases the volume. Now, I was talking about logarithmic potentiometers a few moments ago. So let's talk about that real quick. We'll just set some arbitrary tick marks on a arbitrary graph that doesn't really mean anything. It's just here for visual. So this is going to be distance that the wiper moves, and this is going to be resistance here. Now, a standard potentiometer is going to be a linear straight line. It goes from 0 to 100% linearly based on distance and resistance increase. Now, a logarithmic potentiometer is going to change a little bit differently. Now, a logarithmic scale looks more like that. And a logarithmic potentiometer, it's very expensive to make a logarithmic scale on the conductive material, so they kind of cheat. So what they do is they make it linear to that point, and then they change the thickness of the material so that it changes linearly from that point, but just a lot sharper. And then an anti-log potentiometer, which I actually experimented with for changing brightness of LEDs, because LED brightness does not change linearly with current. So I thought maybe if I used a nonlinear potentiometer, I could control LEDs a little bit more smoothly. It didn't work as well as I'd hoped. But yes, there are also anti-log potentiometers, and of course an anti-log scale is going to look like that. And then of course the resistance of an anti-log potentiometer is going to look like that. Anyway, I hope that clears up any questions you had about potentiometers. If you have any further questions, feel free to ask them in the comments below. If you haven't already, consider clicking here to subscribe. Over here will be a video that YouTube thinks you'll find interesting based on your watch habits. Right over here will be the Back to Basics playlist, and right here will be the Patreon link that you can use to support my channel. Patreon supporters do get these Back to Basics playlists, or Back to Basics videos, 1 week in advance. Thanks so much for joining me this time, and we'll see you next week. Bye-bye.